It's technology.
Let's go.
I did that once when I started. When I first started videotaping, I put my water right there. Which one? No, I'm joking. 1E. Yeah, what do you do on 1E on the practice one?
Totally.
We're looking at the practice one, right?
Yes.
Thank you.
What are you supposed to
When do you need common denominator between fractions? When do you need a common denominator?
when you're subtracting.
Subtracting or adding, right? Because then it's like terms. I don't need like terms when I multiply or divide. But what do I try to do when I multiply or divide with fractions? What do I try to do? I try to reduce, try to cancel, which requires me in this case to factor. Right? Kristen's like, come on, man. Catch up. So then you just factor everything and kill whatever's common, right? Who asked that question? Arvin. Is that cool? So you have to factor each piece?
Okay. Yes.
So how do you factor the top here? What's the first thing you have to do on the top?
5.
Good, if 5 comes out. Alright, is everybody with me so far? Good old GCF saves your ass. If you're not sure what to do, or just in general, you always try GCF first. What about the bottom? This is our favorite one. Alright, let's focus on this by himself for a second.
It's the worst one.
Oh, yeah. Well, I always have people revert to this. No. Because that's going to have a lot of shit, 3x squares and x's and stuff. Nothing's going to cancel. Everything's going to be there. I need a lot of shit to cancel. There's got to be something kind of semi-strange to have stuff cancel. Who remembers what it is? Ooh, I like it. Or what I technically refer to as little dude, big dude. But I kind of like the binomial, trinomial specification even better. So little dude, big dude, or bi, tri, or tri, bi. Whatever you want to do. Yeah, so then this is x cubed is xxx, 27 is 333.
So x minus 3.
So yeah, x minus 3, 1x, 1, 3.
X squared.
And that's always the same sign. Oops, where'd it go? There it is. There's the sign, Jeff. X, the other two x's, x squared, I love it. The other two 3's go there. So I get my x cubed. Yay. I get my minus 27. Yay. And then the middle dude is
3x.
good. It's the cleanup dude. So it's plus
3x.
3x. He cleans up the shit. So I desperately want you to understand. I mean, it's not that difficult to really kind of see how it makes sense. If I put 1x there, the other two got to go there because I got 3 altogether. If I put 1, 3 there, the other two got to go there because I got 3 altogether. And then this guy kills the extra shit I don't want. What extra shit am I talking about? Like minus 3x squared. Do I want that?
No.
No, but then look. That's plus 3x squared. That would cancel it. Right? I don't want 9x. But that's minus 9x. That would cancel it. So that middle dude cancels the extra shit that I don't want. The extra shit that you would have if you thought it was this. Okay, maybe. I tried. Alright, that's 1/4 of the problem. There. So far we got half the problem kind of done. Times. How do you factor the top? That second top?
Take an x.
Good. Take an x out.
X squared plus 3x plus 9.
Right? And notice something already, right? You guys see it? What sucks is when people really start to go, let me try to break this down without realizing, oh, it's already going to die. It's impossible to factor that nicely. Just be careful. You can't use nice whole numbers to factor that. Not even real numbers you can't use to factor that. So it's not factor. Let's just kill it.
5x cubed. 6.
Yeah, the bottom is already factored. Is there anything still not factored? Yeah. Alright, purple. That's great. Yeah, the x squared minus 9. So I got 5, x minus 3, x plus 3, over little dude, big dude, times x, that stuff over 5x cubed. What dies?
X minus 3 and x squared plus 3x.
Yeah, the x minus 3's cancel. And then the big dude cancels.
The
5 cancels.
Equal to.
1x cancels, so what happens down here?
That's, wow.
So what's left on the top?
X plus 3.
Good. X plus 3 over x squared. Can you cancel an x out? Why not, man? I want to. Of course not. You can't break into an addition, right? You cannot do that. You cannot break into an addition with a division. Division is not that powerful. Division can only kill multiplication. Bang.
Perfect. Thank you.
Yeah, sure. That's what I do. Yes?
1A.
Oh, yeah.
Yes. It's an annoying problem.
So, hatred of fractions is not contained only to maths below 100 or at 100 level. It's across all maths for unfortunate. It's unfortunate. So I don't know what to do about the fractions. These 4 fractions. I can never make anybody come to the fraction side, but and part of it is because you don't have to deal with them in everyday life very often, or you've developed ways around dealing with them, right? So the stock market used to be in fractions, but I'm not saying that any of us have anything in the stock market, so that wouldn't really help. But you know, if you did any tool work, you have some fractionals, unless you're using millimeters, in which case they come 8, 9 millimeters, but you have like 5/16 of an inch socket or something, right? So you get a little practice there, but you don't run into them very often where you have to use them. But how the hell do I do this?
16 over 5.
Yeah, so where would I, no matter if there's fractions or what the hell's in there, what tells me what to do first? Which part of this I'm going to focus on first? Yeah, inside the parentheses. I got to do it inside the parentheses first. And how do I do 3 1/5 minus 1/10? He's got a good idea.
5 times 3 plus 1.
Yeah, okay, good. Yeah. So I want to make this into the same format as this, sort of like top and bottom, right? I want to make it improper fraction. So 5 times 3 is 15 plus 1, 16 fifths. And then what do I have to do there?
You gotta find the LCD.
LCD.
10.
10, cool.
32.
32 over 10. 31 over 10 is crazy. And do you see why I call this like terms? 32 of these minus 1 of these is 31 of these. Bam. That's why you need an LCD when you add subtract, because it's like terms. It's exactly the same idea. And what's divided by 31 20ths? Times 20 31sts. Right? So what beautiful thing happens there? Do you just start going, well, that's 610 and 20, and that's, do you want to do that?
No, it's answers 2.
I don't want to do that.
Answers 2.
Why?
Because it cancels.
31's cancel.
And then 10 goes into 22 times.
2. Done. Yeah.
Can we go over one of the tests?
Sure, yeah. Anything. We don't have to focus on the final. We can, on the practice final, we can do anything. Because final's going to come from everywhere.
3, 6D on the test.
Six D. Oh, the inverse. Inverse. So, you know, I'm sure you guys noticed that on a day like today, there's a little more elbow room in here, right? On the day of the test, there seemed to be more people suddenly come out of nowhere. And, yeah, I'm going to rag on these people because they're not here, so who gives a shit? Hey, and do they watch the videos? Probably not. So I'm a little pissed off. But the people that normally are the ones that write me nasty emails or come to my office and they're upset are the people that don't come, don't do their homework. And when they do their homework, it's shit. It's copied from somebody, whatever, right? That's shit, right? So on the test, it's very easy to tell the people that have not been coming because they look at problems and they're like, I have no idea. So some people look at that problem and they had no idea. They just made it negative. So some of you guys had a question like that. Some of you guys had a question like that. But it was all about finding the inverse, right? So it's not the reciprocal. It's not making it negative. None of that stuff. So everybody had a slightly different thing, but I think everybody's had some kind of a root. So let me just make one up here. So let's say h of x is the fifth root of 2x minus 1 plus 7. And I want to find h inverse. So this is one that's like 6D on the test. Cool. All right, so what's the first step to accomplish this? How do I find inverses?
Make y equals
Yeah, put the y back in, because what's the general overarching idea of finding an inverse? How do I find the graph of an inverse? If I give you a function, I just do what with the points? Switch the x and y. So the beautiful thing is, okay, that's graphically, Jeff. That's what do I do algebraically? Just switch the x and y. It's awesome. It's an awesome thing. It's the same thing. So you bring y back in. Of course, that's the dude that we used to call y. So let's call that dude y again. That is y. That's the output, right? That's y. And then I just do this little. I just do that because it helps me out with I have a mild case of math OCD. The next step is I can't do something algebraically to get to the next step. It's an idea. I'm going to switch the x and y. So I'm applying an idea. So I'm going to switch the x and y. Now how do you start to solve for y again? Solve for y again. If you want to get it,
You have to subtract 7.
you gotta solve for y. Sorry. I'm not sure what that song really is, but I put new words to it. Huh? Is it?
No.
Oh yeah, that's the one, yeah.
Or is it down?
Try again. Okay, sorry. Solve for y again.
Subtract 7.
Subtract 7. So x minus 7, fifth root of stuff. So the next main barrier that's keeping me away from my y, dude, is the fifth root. I can't get in there, so what do I do to kill it?
You have to raise the
Yeah, do the opposite of fifth root, which is the fifth power. So I can blow that wall up, right? Here's my explosive charge. It blows that wall up. So now I've got x minus 7 to the fifth power equals 2y minus 1. And now I'm just 2 steps away.
add 1.
Yeah, trying to get the y by itself, so I add 1. They don't like my song choice. And then divide by 2. And then you're done. Divide by 2. So then this is h inverse of x equals this. Whew. That's the opposite. And real quick, oh shit, let me see if I can make this. Well, yeah, I can. What's h of 1? Let's see if you guys can do this. Who is that? What's h of 1? What do we get if you plug a 1 into h? That's all right.
Was that him?
Yeah, that's awesome. Not only am I not going to come to your class, I'm going to talk really loud right outside. It's like, holy shit. All right. So what do I get when I plug a 1 in?
1.
Fifth root of 1 is 1. I love it. The 18 millionth root of 1 is 1, right? Because 1 times itself, 18 million times is still 1. So I get 1 plus 7, 8. All right, so therefore, what should h inverse of 8 be? What must that be? What does the inverse function do?
Is it 1/8?
Whatever h did to 1 to make it become 8, h inverse should do what?
The opposite.
The opposite. So what should it make 8 become?
1/8. No, negative.
It should make it
Negative
become 1 again.
1.
Make it become. So if h makes 1 become 8, h inverse is going to make 8 go back to 1. It's going to make it go back. That's what it does. That's what the inverse does. What's 2 cubed?
1.
What's 2 cubed?
Oh, excuse me, no, it's 8.
2 cubed is 8. You with me?
Yes.
So what did the cube do to 2? It made it 8. What's the cube root do to 8? What's the cube root of 8?
2.
Took it back to 2. That's what inverse functions do, right? So therefore, if we did this correctly, if I plug an 8 into that, my answer should come out to be 1. Is it true? If I plug an 8 in here, what do I get? What's 8 minus 7? 1 to the 5th power is?
1.
Plus 1 is? Divided by 2 is? Holy shit. Alright, you guys see, there's actually a way to check your work on this. Yes, sir.
So this would have been for 6D though, correct?
Yes. You didn't have to do that last bit. That's just me going further like I always do. All you had to do is get here. So some of you guys had a cube root. Some of you guys had a square root. Can't remember. Now I wasn't being overly picky. I'm not going to even make a big deal out of this, but the square root, if you make the inverse of it, it's got to be half of a parabola, but I don't care. That's fine. Yes, sir.
Can you do 6C as well? Just because this was probably the toughest thing on the test.
Oh, yeah. Let's see.
It's like you need to go over this one.
Oh, yeah. So, let me make some functions up real quick. No, screw it. No. X cubed minus 2, and it'll say h of x equals x minus 10. Sure. So how would you do h of f of x? And actually, just to get everybody warmed up, how would you do h of 11?
Plug 11 in.
Yeah. All right. And what if I would have put the number 7 in there? What would you have said?
Plug 7.
Plug a 7 in. And what if I put negative 2 there? What would you have said?
Plug negative.
Plug a negative 2 in. All right, so whatever the hell I put here, you plug it into this dude. That's all a function knows. The function doesn't go, what's in there? No, the function is, whatever the hell's in there, just put it in there. Right? It doesn't even think about it. So h of 11 would be amazingly enough. 11 minus 10, 1. Is that cool? Plug in 11 into h. All right, so don't come up to me and say, which function do I use? I told you which function to use. The h function. There's 2 functions. I'm talking about the h function. Right? All right. So if I say, what's h of f of x, what am I putting into what? Say one more time.
X cubed minus 2 and
Plug it into x. Plug it. How do you?
in the h
In place of x in the h function. I like it. I like it. I don't like how you get really slow there when you talk to people. Let me help you, Jeff. All right. So to rewrite this, f of x is, like you said, x cubed minus 2. So I'm going to put this in h. So in place of x, what am I going to put there? X cubed minus 2. Okay, x cubed minus 2
Minus 10.
minus 10. So it's x cubed minus 12. Good. All right. And whoever asked the question, you're like, still haven't answered my question. All right. So here it is. I'm working my way up.
You're going perfectly, man.
Thank you. So what is h of 11? What do you have to figure out first?
H of 11.
I've got to figure out what this is. And how do you always simplify computational problems? You start from the inside out, don't you? Don't you go to the most inside parentheses, right? Don't you always do it? So we got to figure out what the hell this is before I can put it in this dude. But we know what h of 11 is. So the first thing I do is work this out, but we already did work it out. So this is 1. Now what's h of 1? Yeah, it'd be 1 minus 10, negative 9. So I had a few people that just kind of ignored that guy, and you were hoping, I don't know, you were hoping I didn't notice. You were like, he must mean, you put 2 h's together, it still sounds like, so maybe just replace it with an h. It's the same thing, Jeff, right? No. You guys kind of with me here?
Yes.
All right. So, I mean, I could ask you what's f of f of f of f of f of 2. Oh my God. So you just figure out what f of 2 is and then plug it into f, and whatever you get, you plug it into f, and whatever you get, you plug it into f, and whatever you get, you plug it into f. And you go slowly insane. But do you understand? I mean, I can extend that idea. Just because I put more f's doesn't make the idea harder. It makes the problem a little bit longer. But the idea is still there. It's the same freaking idea. Work from the inside out. Right? Okay. 2. Yes, you were asking a question earlier.
3A.
3A. Okay. So everybody take a second to try out 3A. Just to remind you guys, I will have a answer key for this whole thing.
That comes with cost, right?
Huh?
Oh, you don't want to give it to us today?
Probably because I don't have it.
Oh, never mind. Just give it a try.
So no, I don't want to.
Okay.
No. Well, I desperately want to, but I don't have it yet. Asked me, didn't make it yet. Stupid dude. All right.
Oh shit, it's in the practice one.
Totally. All right, so then you get, what do you get? What happens?
Plus 9. Or my times right.
Yeah, this always sucks when the very first step, somebody puts a plus there. You know, you better, thank God I'm a partial credit kind of guy. There are teachers out there that will give you a 0 if the answer's not right, which personally to me is crap. Because then, you know, there's differentiations between 0 and some partial credit. Maybe that's the only mistake you made. You deserve some credit. Not a big mistake, but all right. 4x
Minus 5x. Plus 5.
plus 5.
Plus 3.
All right, cool. All right, and the whole reason we distribute first is so now we're able to get our stuff together, right?
Huh?
You talking to me?
No. Now I am. Here you go.
Thanks, sir.
All right, so what happens now?
Minus.
Negative x minus 9 equals negative x plus 8. That's interesting. So if I add x to get my x's together, I get negative 9 equals 8. And this is where people make x magically stay, but you don't care. This is easy now. Don't stop and circle that. Don't tell me that 8 equals negative 9. What's the answer? Good, because when is that true? Remember, the whole idea of solving an equation is when this is true, then this is true. This is never true, therefore this is never
So
true,
there's no solution.
therefore no solution. No x saves this equation's ass, right? It's dead. No solution. This is not math's fault, by the way. There are situations in real life where there's no solution. What can I do? Or let's see. I remember my first car was a Dodge Charger, 84 Dodge Charger. And it died a slow death. And what could I do to make that Charger like go 200 mile an hour? If I set the equations up, the equation should come out like this. Because it's like, math is saying, no. This is not going to happen. So it's real life. Real life has situations where there are no answers. Right? And I know you got movies, there's always a way. No, sometimes there's just ain't a way. You can change things, sure. Then you change your equation. If you have a company and you want to make $5 million next year, the weight is now no. The equations say no. All right, well, let's add more people. Let's get some more funding. Let's do that. Well, now you're changing the equation. Maybe now it'll have an answer. Do you understand what I'm saying? All right. I don't want to make you down. The equation says no. That's it for me. No, you can change the equation. All right. Evan, right? You gotta love it when there's a problem that goes out to N. That one goes out to Q. That's awesome. So 1N looks freaky as hell. I love this problem. You would, Jeff. Why can't I just multiply them? Yes, cool. The roots aren't the same. You can only multiply. So if I had square root of 7 times square root of 2, that's square root of 14 all day long. But if I had square root of 7 times cube root of 2, no. So what the hell? Do you just stop and circle that? No, because you'd be wrong. They do have like what? They have like bases. Because how can I rewrite the cube root of x? X to the 1/3 power. How could I rewrite 4/3 of x cubed? X to the
4/3.
Careful. Roots are where on plants? On the bottom. So roots go on the bottom. So if you see, so it'll be 3/4. Roots on the bottom, powers on the top, because powers are powerful. Up on the top. Whatever makes it stick in your brain. And now they got like bases. So what can I do with the powers? Add them. And that doesn't mean you can just make it 4/7. You said add. Well, they're fractions, so how do you add fractions? LCD. Right? Good. So it'll be x to the 4/12 plus 9/12 equals x to the 13/12, which you could stop there. That's fine. Or you could do what?
13.
Careful. Where are roots? On the bottom. So it's the what root? 12th root of x to 13. And believe it or not, you could get one more step because 12 goes into 13. 12 goes into 13 once. With how many left? 12 goes into 13 once with 1 left.
But
and what is
all three? I'm sorry, all three of those are correct though?
Yeah, you can stop there. Fine. If you want to make it in a root form, that's fine. If you want to simplify the root form, that's even better, right? So that's its ultimate form there, right? This is algebra saying 3 here, right? Just make another joke on it. And look here, look how this makes sense. What is 13/12 as a mixed number? 1 and 1/12. A whole x and 1/12 of an x. 1 and 1/12 of an x. That's what they say. So both of these things say the same thing. A whole x and 1/12 of an x. Because the 12th root will cut it into 12 pieces. That's 1 whole x and 1/12 of an x. That's enough of that. Yes, sir.
On the test, 9F.
Oh, so let me make one that's sort of like what everybody had. So nobody had this problem. Everybody had a problem like this. All right, clogged there at the end. So I want you to combine these into one log. So what do you have to do first? I know what log base 7 of something plus log base something or minus something. I know what to do with that, right? What's log base 7 of A minus log base 7 of B? Log 7 A. No. When you subtract powers, when you were
A over B.
dividing. Because remind yourself, logs are powers. So if the powers are subtracting, the arguments must have been dividing. Because that's when you subtract powers, right? If that was a plus, this would have been a... when you add powers, when you were multiplying. I like it. See? So the properties of logs are the same as the properties of powers. So what does that have to do with that? Well, I don't know. If there would have been a 4 here, I don't have any rule for 4 log. I have a rule for log of this minus log of that. I got a rule for log of this plus log of that. I don't have a rule for 4 log of this. So how the hell do I get that 4 to get the hell out of the way? How do I get the 4 out of the way? What's another property I can use of logarithms? Where'd that 4 come from? Because a log has an interesting property.
You can move it to the...
Yeah, you can bring this back up here. Remember the property where it takes powers down? Because when I raise something with power to a power, I multiply the powers. That's still the property of powers. So what can I do with this 2 ninths? Let me say I got log base 7 of m to the 4th. What can I do with this? I'll tell you to do that, Jeff. Yeah, bring it up here. Minus log base 7 w to the 2 ninths. What can I do with that c? Probably the same exact thing, right? Because the properties don't care what's there. C is there. Oh, do the same thing. Now W is there. Oh, do the same thing. Now 2 ninths is there. Do the same damn thing. Right? Math just has a property, and whatever's there goes.
So log
that C
base
goes
7
up.
C, D.
What's that?
Log base 7 C, D, C.
I like it. Freaky shit. Freaky shit. Now I can do this. And this is where people messed up a little bit. I want you to see if I want to see if this makes sense. What's the only positive thing up there? The log that has what inside of it? What's the only one that's positive?
The first one.
The first one, the one that has M4. So that's going to go on the top. It's positive. The other two I'm going to divide by because they're both minuses, right? So on the bottom I'm going to put this guy and this guy. That's the quick way to get there. Some of you guys had the right answer just written wrong. You had something over something over something. It's like, that's a nice cake when you have like a 3-layer cake, but it's not good for algebra. Technically it was the right answer, it's just written in a wrong way.
What if you have one fraction and then one whole number that are supposed to be in the bottom together? Do you write them together? Like, for example.
Total, yeah.
Okay. So it would be, say that C was actually a 6. It would be 6 and 2 ninths.
Say the 6, C was a 6 here? So that would be a 6 there? That's all.
Okay.
Yeah. Is that cool?
Yep.
Yeah. So this property is not dependent on there being a W there. It's not dependent on there being a C there. It's just whatever's there goes in the right place. And I know that, we just barely got into logarithms. So we don't see the utility of this. We did a little bit. I think I showed you guys how to do a problem like this, right? Yes, I did. So I'm going to not even wait for anybody to say no, because I didn't. How do you solve that? You can do it, come on. How can I rewrite that logarithm in a different form? 7?
7 to the 1 power.
To the first
Equals x minus
equals x minus 1. So then x equals 8. Check it. 8 minus 1 is 7. What's log base 7 of 7? What do you raise 7 to get 7?
1.
First power. Just recheck it, right? So real quick, just to show you one thing here. I think I said this before. And there's a problem on the test that has a problem like this, but it's not an equation. There's a problem that was sort of like, but if I made an equation, I could actually do something with it. So what does this mean to do with these two logs? Yeah, so it'd be log base 7 of x minus 1 squared. And how do you simplify this? What happens there? Yeah, one of these x minus 1's cancel. And then it's the same. Look at that. So if I had several logs here in an equation, I can combine them all using the properties we learned so that I can then solve that equation. That's the first and most immediate usefulness of knowing the properties of logarithms. Right. Some of you guys are like, joke's on you, man. I'm never going to use math again. Once I pass this class. Oh, well, at least you've seen this stuff. It's out there. Logarithms are used every day, believe it or not, especially in California. Right, with earthquakes and stuff. Richter scale and all that kind of thing. All right. And that equation solved with that. So anything else from anyone? Homework, anyone? Yes?
8. I don't know why that was a super weird thing.
Oh! So again, yeah, I had a lot of people. I was kind of... well, I had more people than expected. I'm going to make it very simple. So let's say I was here. So this is the point, -4, -2, right? This is the point. What point's that? Who to what? 0, 2. And then this is the point 2, 4. Is that cool? So if this is my... That's really boring. That's too bad, Jim. Oh, well, you're not going to make it all that exciting. Let's make that 1, 5, so it's a little more interesting. So if this is my function, how do I make its inverse? How do I make an inverse of a function almost any way? Switch the x and y. Now, a lot of you guys are just doing it visually, which is not good enough. You're just kind of visually trying to make it, which is, on one level, it's good, because you know it's supposed to be symmetric, but it's not good enough. You have to get the exact answer. So some of you guys are just sort of eyeballing it and saying, well, it's going to be, no. Trying to make a mirror there. So all I got to do is, that's -4, -2, so mine's going to go through what point? -2, -4. Some of you guys made it not negative anymore, but the rule is you take the x and y and you switch them. That's all the rule says. So don't mess with their negativeness, right? That goes through 0, 2, so we're going to go through, that's crazy. That goes through 1, 5, we're going to go through 5, 1. So -2, -4, 2, 0, and 5, 1. So it's going to go. So you can see the symmetry, right? Symmetry. Okay. Maybe. So you guys had a little more interesting one on your test. I should have come out with a nifty kind of looking spaceship kind of thing at the end. Yes? 4A? Before? Oh, in the practice. Yeah, I want to talk about 4 also in the test. 4A on the practice final. So I think difference in sum of cubes is the clear winner, but the clear second place is this one for most hated factoring form. So the first number is not what? That would make this easy.
5.
The first number is 5, but it's not what? What would be there to make this easy? 1. So anytime the first number is not 1, then things are going to be a little bit harder.
Yes.
So a good thing to notice, like Greg said, is there's not that many ways to factor 5. So you could try trial and error. Just write 5x and try something and make until it works. So there's not that many.
Just times 5 and 6. Just times 5.
Yes, I like it.
-6.
Okay, cool. So if you like the trial and error method, you are probably somebody who does not need too much help from me, right? Because that means you are decent with playing with numbers. You can probably do these kind of things pretty quickly. So let's see, how can anybody who wants to do this, maybe somebody who's not as good playing with numbers, how can they do this? Well, like Arby said, when you have a number A that is not 1, you multiply those together, and then you do the same thing you always do. You try to get two numbers that add to be -7 and
Come up to be -6.
multiply to be -30, right? Yeah, cool. So eventually you'll get, so if you try 6 and 5, that's never going to make 7. You try, what else? It's almost impossible not to go for 10 and 3, and of course that's going to work as long as 10 has to be negative. That's how you get -7. You guys semi with me. That approach to getting the two numbers that make the product and the sum work is what we do if there was a 1 there. It's the same thing. The only difference when there's not a 1 is this has got to be taken into account.
So it's now 5x squared minus 10.
Yeah, so now we rewrite the middle term. Now be careful, when I just do this,
No.
what's missing?
XZ.
XZ. It's got to, whatever you rewrite the middle as has got to work back out to be this. If they don't have XZs, how the hell are they going to have XZs? So you give them XZs. And then, of course, at the end, minus 6z squared.
And then you divide by 5.
2 to what? Yes, well, sort of. What do I do now? Why did I do this?
Divide by 5x.
Because now I have groups, right? I love it when people just add these back together, and then they're like, I don't know what to do from here. I'm like, why did you do that? You did all that work to break them up and you just put them back together. It's like, no. So yeah, what comes out of here? 5x, I like it. Good. And remember, this is not that hard to see, but you got to make it look like an X. And to make it look like an X, you got to take a 3Z out. And I know this is going to work because I got two numbers to work. Right? And everything's where they're supposed to be, so it's got to work. So if I take a 3Z out, I'm left with minus 2Z, yeah. 6 divided by 3 is 2. 6Z squared divided by Z is Z. Comes.
That's the final answer.
No, it's
No. You gotta add them together, but then that's the final answer.
no.
Okay, you know what I mean, man. 5
No,
plus
no.
3z, and then plus x
Okay,
minus
alright.
2z. That's what I'm saying.
So 5x plus 3z, because you can take out the x minus 2z.
Just came out wrong, that's all. That's the final answer.
As long as it comes down on the paper correctly, it's alright. Be glad I'm not doing an oral final.
Yeah. Love it.
If you're going to grad school, that might be in your future. Oral final exams. Here, this is your room. I'll give you a problem. And then I'm going to come back and you explain it to me. I told you that story, right?
No.
Physics, it was my quantum physics final. And he gave each of us a room. And he gave us a problem, this impossible problem. And he said, I know it's impossible, just tell me what you can do with it. I'm like, shit. And the lady next door to me, a really good friend of mine, had a nervous breakdown during the test. And she's over there, I can't do this, I'm never going to get it. And he's like, just keep working, Jeff. And all right, that's it. So just be happy that you're not in that boat yet. All right, but it might be in your future. It's exciting. Good, you build character. She eventually passed the class. It was good. Yeah.
On the practice funnel, 1i.
1i. Oh. By the way, Sue, if you watch this, I'm sorry about telling this. If they don't know you, it's all right. This is 1i on the practice final.
No, I'm sorry, that's a different one.
Which one do you want?
Yeah, you know what? That's good too, man. Yeah, go with that as well. That's a good one.
Oh, okay. That's awesome. You're doing fine. Keep doing what you're doing. Yeah, people have a problem with this too. This one should not be that evil. It really shouldn't be. Right? I mean, again, there's a process. The process here is FOIL, or whatever you want to call it. I like repeated distribution, but FOIL, sure, what the hell. The FOIL process doesn't care that these are radicals. We do. So what's that? Square root of 15. Cool. Now, I love it when people do this kind of thing and then they get there. Now, can you help me figure that out? Now, I'm not coming down on you because I think you feel like there should be more. So you force something that just doesn't follow. But square root of 3 is not 3, right? So there's just nothing. 15 doesn't have 2 of anything. So you can't take a square root of n. So 15. And then what do you get there?
2 squared, 35.
Good, I like it. And of course I get 10 root 7 or something, right? But you got to multiply the root stuff together. And what's in front of the root 5? A 1, right? So then the 1 times 2 is 2. See, the numbers on the outside go together, and the numbers on the inside go together. Aww.
That's very nice.
And what do you get there?
Negative 2, 6. Negative 2, 9. Whoa.
All right, negative 2 rad 9.
Yeah.
And some of you guys remember that rad 3 times rad 3 is 3. But you're going to get 3 on the next step anyway, so just leave it there. And what do you get here?
Negative 4, 21.
Negative 4 rad 21. I like it. And then the only thing you can do is this. Like we said, rad 9 is 3, and that's where people are saying 2 times 3, 6. Please don't put any of that stuff together. Why can't you add any of that stuff together? There's no like terms up there, right? Not a single like term. So, just if some teacher in your near future gave you a problem that said simplify this, it's just like me saying reduce this. What am I checking to make sure that you know that you can't? How would you simplify this? You'd circle it and say, there, Jeff, I'm done. I was done before you handed the test to me. Good, that's what I'm testing you about, right?
Yeah, that should
So
be
I don't know.
man.
That just, I don't know. It might, that kind of problem might happen. I know the guy making the test.
That should be a bonus question, Seth.
I'll be quiet.
Just saying.
You want your bonus question to be easy and the other question to be hard? I can do that. Yeah.
5, 8.
Oh, good. All right. So this is going back a little ways. Can somebody tell me one equation of a line? Yeah, the infamous one, y equals mx plus b, right? Not bmx, is too bad for you. Mx plus b. Does anybody know another equation of a line?
I think it's to find the slope. It's y2 minus y1 over x. Oh no.
Well, yeah, over the x's would equal m, so then you multiply the x's up and you get a whole nother equation of a line.
Oh yeah.
See, if I put those back down here, if I divided both sides by that, it would be the definition of slope, basically. They said now I'm letting these be anything they want to be. Because what's the whole idea of a straight line? Do I have to pick certain points to have the slope? I can pick any freaking points I want to, and they'll always be the same slope, or else it would turn and it wouldn't be a straight line, right? You guys kind of with me? Okay. So either one of those, you can use either one of those. So this one says, find the equation of the line that has slope, m equal negative 1/3, and it passes through 0, negative 5, right? Yeah. Do you guys realize why that is a problem you so much want to get? What do you need to know for this? To use that, what do you need to know? 2 things. Slope, y-intercept. What do I know? Slope. Holy shit. So what's the equation of the line?
Y equals 1/3.
Negative 1/3 x plus negative 5. So just minus 5, 11. And you're done. It's just a plug and chug then. It's just to realize that you have everything you need. So I love it when students are like, this one was hard, that was me. This one was too easy, that was me. I'm like, holy shit. So that is almost too easy, and people make more of it than what I'm intending for it. I need to make sure you can identify the easy problems. I need to make sure you can say, oh, I've got everything I need, just put it in. So what about part B? That gets more interesting. What's up?
Are you still doing? Oh, okay, we're still doing it.
I'm done with that. I just wanted this equation. I got the equation.
Huh?
What about part B? I like part B.
Plug it in, right?
Part B is awesome.
X and Y. Negative 4 times 5. 2 equals.
No, come on now. All right, now listen.
That was correct, I think, no?
No.
It's not correct.
This equation, this line, is that my line? What's true about my line in relation to that line? We are
Parallel.
parallel. No, that isn't quite right. Right? So my line is parallel to that line. I can't plug shit into that line. All I know about that line is that it's parallel to mine. Now what does that tell me about my line? What two things do I need again? Slope. Y-intercept or a point. If I can't get the y-intercept, I'll take a point. Right? Just some information. So do I know my slope?
Yes.
What's this guy's slope?
5.
And since I'm parallel to him, my slope must be 5. If I was perpendicular, my slope would have been negative 1/5. I love it. Parallel, exactly the same. Perpendicular, completely opposite. And how many opposites do we know? Change the sign, reciprocate. Right? So if this would have been perpendicular, my slope would have been negative 1/5. The negative reciprocal. But it's parallel, so my slope is 5. Right? But just in case perpendicular comes up. All right, I'm going to stop. Yes, but it will be on the test, all right, there. And what's the second thing I need? Do I have it?
Y-intercept.
They give me a point to be okay with it. So I have two things. I have the slope, and I have a point. You can actually use either one of those equations. The second one is nice because it has a place for an arbitrary point, right? But so does the first one, really. Let's use the second dude. So here's the second dude. And really, behind the background here, behind the scenes, is if I ask you find the equation of the line, let me put the whole thing, of the line that, blah, blah, blah. I need two things from what I tell you. I need the slope, I need a point. Whatever I tell you, you need to find those two things. Once you get those two things, you do the same damn thing. You plug them in. Yeah, this is STT level. Same damn thing. So what do I put here?
2.
Beautiful. The Y piece. 2. I love it. What do I put there? That's crazy. And what do I put there?
Negative and negative 4.
Yeah, good. And people do that. But that's not right, is it?
No.
There's a minus in the equation, and the number is negative. Right? And that happened to a few of you guys with the vertex, the negative b over 2a. Or even in the quadratic formula, negative b plus or minus. There's a negative in the equation. If b is also negative, negative, negative becomes a positive, right? So here, what am I going to get? Y minus 2 equals 5 times x plus 4. Distribute 5x plus 20 plus 2. Just to simplify it a little bit. Is that cool? I was just cleaning it up. You guys could do that. And again, this is all going to be the answer key that I will give you on Thursday. Wow, holy shit.
Well done, Jeff.
Can you do one more?
Yeah, sure.
On the test, 6D. Or maybe not, because we still got to correct that one, huh?
6 what?
6D.
Oh, we did that first thing.
We did that.
So it's on the videotape.
Okay. Cool.
All right, so we'll on Thursday Try more of the practice final out if you have time. Your most important thing is to do any homework you have not done. The second most important thing is to make corrections to anything you haven't made corrections to. And then the third most important thing is to try this. That is the order I would attack things in.
And the exam's on the 28th?
Yes, it's on your grade sheet I just gave you. It's on the syllabus.